Good morning, friends. We start Aws D 1.1. So already we see there is figures 8.1, 8.2, 8.3. Let us see also this 8.1, let's see. Figure 8.1, discontinuity acceptance criteria for statistically loaded non-tubular, statistically or critically loaded tubular connections. So non-tubular and tubular connections. Eight point 12.1 and 10.25.2 for tubulars. So any of the figures they will give, there is, but they are give you in inches because they are working in inches. Americans work in inches. So S is the weld size in inch and C in inches. What is C? Well, C. B is the maximum size of discontinuity in inch. So what is C? Minimum clearance measured along the longitudinal axis of the weld between the edges of porosity or fusion type discontinuities. Larger of adjacent discontinuities governs, or to an edge or an end of the intersecting weld. The minimum clearance measured along the longitudinal axis of the weld between edges of the porosity or fusion type discontinuities. So this is, and W is the smallest dimension of either of the adjacent discontinuities. S is the weld size, T is the plate thickness or pipe thickness. So if this is the figure, then what you do? S is the weld size in inch. They will give you weld size. The maximum size of discontinuity you have to find. So from here, you just drop it here. And then drop here to find out what is C in inches allowed. So from question they will ask just that one. They will give this higher or say 5/8. If you go for 5/8, you find somewhere here. And that is around, you have to count it like 1/8, but here 1/4. And that is the problem here. So after 1/4 here, it is directly going up here and 3/8 here. So in between, just divide this, add this 2 and divide it by 2. Don't go for other things. And if you just divide it direct, you'll find a easier way to do it. It is up to you what you have to do. And same here. Half means 0.5. So 5 by 8 means you can calculate 0.625. So they will give you in 0.2625. They will not give you 5 by 8. So that is the problem. What they are doing. They just try to find whether you know 3.5 3 by 4 is 0.75 or not. So only mathematics check, but you will find it difficult to answer. Then you lose your numbers. So key for figure 8.1, if there is a discontinuity like this, what will happen? If there is a discontinuity here, what will happen? Or discontinuity at weld intersection case 1. So L is the length of this discontinuity, the highest dimension. You can sell, this is the length, L, less than S by 3. And less than 1 by 4 inch, 6 milli. Conditions as less than 2 inch, 50 mm. So if S less than 250 mm, then this condition is valid. L is the less than S by 3 or 6 inch, less than equal to 6 millimeter. Less than equal to 10 millimeter if 3 by 8 inch, if would have been greater than 50. That is how they are counting. And in exam you have to find out the answer. Same C1 is the greater than equal to 3L. So C1 is, here is the distance between these two. So greater than equal to 3L is okay. So one discontinuity rounded, the other rounded or elongated. So L is greater than equal to 3 by 32 inch, 2.5 mm. So here L is the greater size of L. You cannot take this small size of L. So the great size of L is here. You have to count. Discontinuity at free edge. So free edge, you have to find this C1. Same like the top. So you have to find out. All the things will given to you in the exam. So if the pictures are given, you have to find out the answer. Case study is 2, case study is 3. Case study 4. Discontinuity or acceptance criteria for cyclically loaded non-tubular connections in tension. So there is no in tension in here. Only cyclically loaded. So if they give two graphs, then what you have to choose? So you have to read the graph carefully. Which graph you have to choose and all. If they just want to puzzle more. Same thing here. Also, same S is the weld size in inch. Is 1.5 inch or greater. There it is smaller, I think so. Maximum size of discontinuity. And C in millimeters. L and W, largest and smallest dimension respectively of discontinuity A. So this is the maximum. If you have 0.75, then you go for 1.4 about. And you have to 1/4 the maximum distance between these two discontinuities. That's all. That's how you have to find out all these figures. Let us go for something else. There are many things, you just go through this. And then comes table of dimension of IQI. So 5 to 20, 21 to 59, 60 to 179. A, B, C, D, E, F. There are dimensions. A, B, C, D, E, F. The dimensions are given. And the IQI thickness is given. Then IQI thickness and hole diameter tolerance is given. And this is wire type penetrometer. So wire different size wire identity 1, 2, 3, 4, 5, 6. So wire diameter in mm, but you may need in inch. So it is here in mm. And the side one in inch 0.0032. So 1 to 6, then set B, set C, set D. It is same ASME. Because it is STM. How you put different IQIs, that is the position they are giving, RT identification and hole type or Y type IQI locations on transition joints, on plane joints. Approximately equal thickness joints 10 milli. Approximately equal thickness less than 10 milli. That's what is given. This is the taper joint. Less than 10 inch. Transition joint less than 10 milli. And this is I think greater than 10 milli or RTF edge blocks. Ten inch or greater length in length. And this is less than 10 inch. I think so. 250 length. So if it is less, only one. This two. But if it is more, two all. This is hole type 3. Is the edge RT edge blocks. So 8.7, 8.8. There also same given. Something just copied, you see it. I'm not going too much to it. Up here.